Okay. Hi, everyone. Welcome to Everest Lab's newest webinar, The Operational Blind Spot Costing Your MRF Thousands. Before we begin, I'm going to go over a few housekeeping items. First, we are recording the webinar, and I will be sending out the recording sometime in the next week, so keep an eye out for that. As I said, we'll be doing Q&A at the end of the webinar, so if you have any questions, feel free to pop them in the Q&A chat at the bottom of the screen. Really quickly, I wanted to introduce your presenters today. My name is McKenna Phillips. I am going to be your moderator. I'm a marketing manager here at Everest Labs, and I have been here for almost 4 years now. And I'll have Ted introduce himself.
Yeah, thank you, McKenna. I'm Ted. I'm one of the solutions engineers here at Everest Labs. Been here for about a year, but I spend most of my time in MRFs from the first walkthrough up to getting your systems live.
Cool. So with that really brief introduction, I will have Ted take it over and give you guys the great presentation he's put together.
Here's where we're headed. First, why these costs stay hidden. Then the specific blind spots and what each one is quietly costing you. Following that, where in the plant it's worth putting eyes. And finally, we'll finish with a few real results and where to start. Next slide, please. 1 minute on who we are. Everest Labs builds AI for recycling. Our platform puts 3D vision and recycling-specific AI models on your lines so you can see every object, understand it as a live composition, purity, or loss data, then act on it, tuning equipment, targeting recovery, and adding robotics where physical recovery pays. Think of it as an agent for plant operations that augments your team, not a replacement for it. The mission is simple: no recyclable left behind. And that one idea, seeing everything, is the thread through the rest of this talk. Next slide, please. So let me start with a question. If I asked you right now, to the dollar, what your plant sent to landfill last shift, could you answer? Almost nobody can. Here's the core problem. Material in a sort line is moving 300 feet a minute or more, and your best picker gets a fraction of a second per object. They are working a blur. So how do most plants measure what is actually in the stream? Maybe through a manual audit, where someone pulls a sample, sorts it by hand, and weighs it a few times a month. That's a teaspoon out of a river. And by the time those numbers come back, the material has already changed. Everything I'm about to walk through lives in that gap. The space between what is really happening on your line and the last time anybody measured it. It's an old line, but it's true here. You can't improve what you can't measure. Next slide, please. The last chance line is where this starts. It's a belt at the end of the system, the one you cannot really staff, and by design it carries whatever the plant did not capture upstream. Because it's the reject stream, no one owns a number for it. So material you worked hard to bring in leaves as residue without anyone accounting for it. The Recycling Partnership put in a 2024 report that up to a quarter of used beverage cans are missorted at a typical MRF, and CRI's numbers state as high as a third. When we put visions on those lines, it gets more concrete. At the largest commingled MRF in North America, it turned out they were sending roughly 200 tons of recoverable material to landfill every month, which came out to over $400,000 a year on that one belt. It is a double cost, losing valuable revenue and paying a disposal fee to bury it on material that was sellable the whole time. Translating tonnage into dollars is something we work out with each operator. That is the real reason your own losses matter. So an AI would help you identify those losses and provide you recommendations on how to improve your recovery. But now it's time to focus on the other side of the plate. Next slide, please. Bale quality runs into a similar problem. Purity drift gradually over a shift, so the first signal an operator usually gets is a deduction or rejection from their buyer after they've already shipped it out. The tolerance is narrow. Most OCC buyers work with a 2 to 5% contamination window before penalties begin. By adding an AI camera, you can start monitoring purity at the QC and pre-baler lines, which helps you in two useful ways. First, by certifying a bale is on spec before it leaves the building, allowing you to hold your own numbers up to a vendor and pushing back when contamination claim does not match what was measured. Second, the less obvious benefit is that catching purity in real time can help avoid recirculation altogether. So you can start identifying and correcting upstream issues while it's happening, rather than pulling finished bales, breaking them back open, and running that material through a second time. All of which is capacity and hours we can't get back. While we're on the topic of upstream corrections, that's where we get to our third blind spot. Next slide, please. Throughput losses are quieter and easier to misdiagnose. Maintenance outages, changes in materials, and shifts upstream, they all create surges. And those surges lead to uneven burden death, which caps how much our plant can actually process. When a bottleneck shows up, it usually gets pinned on the wrong machine because it's being diagnosed by feel rather than by data. What actually caps a plant on a busy day is rarely the max throughput of the equipment. It's the clumps, surges, and material riding over the top of a screen instead of through it, none of which shows up on that monthly report. By strategically placing cameras throughout a recycling facility, the actual system constraints come into focus. Addressing and stabilizing those bottlenecks enables facilities to recover material that would be otherwise lost during periods of peak throughput. Operators who've implemented this approach report recovery gains of up to 18%, which is capacity that was already in the system previously went unrealized. These bottlenecks, surges, and trends have always been hard to pin down because the checking was manual and periodic. AI, however, makes them measurable, which means processing more with the equipment you already own. Then speaking to those bottlenecks, the next blind spot correlate and potentially causes those surges and leaks. Next slide, please. Downtime. Downtime is the operating cost people tend to underestimate. A common issue, tanglers. Films, bags, hoses, cords, they wrap around those screen shafts, building up until the line inevitably has to go down, after which someone has to climb up and cut it free. It's one of the most common causes of unplanned downtime in the industry. The city of Phoenix has put a figure on just the plastic bag portion, roughly $1 million a year in lost time for machine jams. The alternative to reacting is monitoring the equipment health and film buildup continuously, so the data feeds predictive maintenance and failure alerts, while also watching black belt for accumulation as they start to form. The point is to catch a wrapping screen or a failing part before it stops the line, rather than after. This capability doesn't stop at just films. Tracking your belt health in terms of its threading, dangerous materials on the belt, or other key concerns operation managers actually care about all become possible through implementing AI. That is what Everest Labs is doing in the background, tracking equipment and plant level KPIs while flagging them against the thresholds you set. Take a simple use case. You have a line that runs into a 2D, 3D polishing screen. That screen has two outputs, your fiber overs and container unders. Put a vision on the infeed along with the outputs, and you create a closed loop you can balance. Everything that goes in has to come out one of those two ways. So when the film count going in stops matching the amount coming out across both of those lines, that gap is telling you something physical. The film is not leaving, it's wrapping those discs. That is a maintenance ticket you can schedule for the off shift, rather than a wrap that keeps building up until it forces you down mid-production. There's the value. Not just seeing composition, but seeing what the obstructions are doing to your system and catching the trend while it's still a trend. Even tracking the material on the line can be used to not only and find potential downtime causes before they become an issue, but it can also be used to better understand your facility and how it runs in real time. Next slide, please. The next one is really about the cadence of your data, and it comes in two parts. The first is that most plants are still running off a quarterly snapshot. A manual audit tells you where you were last quarter, not where you are now. And any fixes you make off it tend to drift back within a few weeks. Real-time data behaves differently. You watch trends form, you benchmark one line against the other, allowing you to hold an auditable record you can hand a buyer or a regulator. And to make it even easier, we can push that reporting and those notifications straight to your team. The compliance piece matters more each year. 7 states now have packaging EPR laws requiring producers to report packaging data, with penalties reaching $50,000 a day in some jurisdictions, meaning tracking around the clock rather than at the deadline is becoming a legal expectation. So rather than scrambling to do that manual audit by breaking down those bales and doing those manual counts, you can achieve those results in real time, each day, at the drop of a hat through a couple clicks. But even beyond avoiding time-consuming tasks, you can get more granular than that at a line level. Next slide, please. The second part is composition, tracked line by line. The trap most facilities fall into is that composition data gets captured, filed in a report, and then nobody acts on it in time to matter. Some of that is a coverage problem. A manual audit samples well under 1% of the stream. So it's a periodic snapshot at best, while an AI camera reads every item. The value comes from feeding the data forward rather than filing it away. The operations team can take those measurements, tune upstream opticals to optimize the stream, or you could utilize a plant-based AI to create a closed loop that adjusts the plant in real time. That is the practical difference between having data and using it. The system does not wait for someone to read a chart and make a change. It simply makes the change itself. Next slide, please. Now on to the next slide. Most operators already have a sense of which routes bring them trouble. The gap is proving it. Without data, it stays a hunch, and a hunch gives you no leverage when a contract comes up. The recycling partnership puts the national average inbound contamination rate around 17%, and over 40% in some areas. A camera on that in-feed gives you a directional read of what is coming in, letting you map contamination back to a region or town, which turns into something you can act on, whether that be targeted education to the routes that need it, contamination priced into the contract, or material pushed back to the source. The honest limit is that a very large facility where every load is commingled, tying material to a specific truck is hard, and really wants a dedicated sampling line or some added additional steps. Even there, though, in-feed vision gives you a directional picture of what is entering the system, which is more than what most plants have today. Next slide, please. The last blind spot is workforce optimization, and it's worth being precise about what that means, because it's not headcount cuts. In most plants, positions are staffed the way they always have been, not based on where people actually add value. Line level data shows you where that is, which lets you move people off those worst positions, meaning those dirty, repetitive, unsafe last chance spots, and onto where their judgment matters. The framing that holds up is augmentation. This is an agent for plant operations meant to support the team, not replace it. Alameda County Industries, also known as ACI, is the best example. The data guided where efforts were best spent due to staffing issues. The system took over the last chance work, and it came out to over 59% lower labor costs at over 99% uptime. The robotics did the physical recovery. The data drove the decision, and the people were moved into better and safer roles. Next slide, please. So the fix is not more auditing. It is putting vision at the handful of points where value is actually made or lost. Four of them cover most facilities. At the infeed, so you know what you're getting and possibly from whom. On the sorted lines, so you know the purity and how much you're capturing. At the pre-baler, so you know a bale is on spec before it leaves. And on the last chance line, so you know what you're throwing away. Each of those answers a question most operators can't answer with confidence today. And because it's continuous, you're not sampling anymore. You're counting everything. So let me put a number on each one of those. Next slide, please. I've thrown a lot of numbers at y'all. So let me bring back some key stats. And notice, every one of them starts with the data, not the robots. Industry-wide, the Can Manufacturer Institute finds up to a quarter of used cans are missorted at a typical MRF. And on our own 2-year study, put losses at facilities around 27%. So this is systemic. At the largest commingled MRF in North America, the data revealed nearly 200 tons a month going to landfill and identified over 400,000 a year in recoverable plastics, and it paid back in 3 months. At another facility, the data alone cut their monthly landfill loss from $43,000 to $15,000 just by tuning in eddy current and optical settings. No robot required. And that is over 300,000 a year. A third used the data to find about 380,000 a year in HDPE going to landfill, recovered $250,000 of it, and moved 4 people into safer jobs. Different facilities, same lesson. The value was always there. They just could not see it. All it comes down to is that you can't improve what you can't measure. Next slide, please. So let me bring it together. The data pinpoints where your workforce and equipment actually pay off. That is the workforce optimization that got ACI to 59% lower labor costs while moving people into better jobs. The payback is real, typically somewhere in the hundreds of thousands to over $1 million a year for a facility. And if you take one thing away today, it is this. The material is already telling you where your money is going. You just need something fast enough to listen. If you want a place to start, it's almost always that last chance line. Put eyes on what you're burying, get one real number, and the rest of the conversation gets a lot easier. You can't improve what you can't measure. Next slide, please. That's what I've got. Thank you all for your time. I'd love to talk about your specific lines. My contact info is on the screen. The easiest first step is usually just a walkthrough of your last chance line. Okay, now let's take some questions.
All right. Thanks, Ted. That was great. So we're going to open it up for some Q&A right now. If you guys have any questions, feel free to pop them in that Q&A chat at the bottom of your screen. Let's start with Ted. How long does a site survey take and what does it entail?
Thanks for the question. Usually when it comes to a site survey, it'll take anywhere from an hour to maybe 2 hours top, depending on how big your facility is. It really depends because when I'm on site or one of my coworkers is on site, we'll really sit down with you first to understand your facility and the flow before we want to go out and walk the facility. And then we're really going to try to dive into your questions and what you really want to get out of utilizing some visions or potential robotics on site. So after that, just gather the data and go. So it really just depends on a site by site basis.
Perfect. All right. Next question. How long does it take for the AI to start being helpful to my operations?
It can be pretty quick. It's mostly a matter of us first defining where you like the data. We have a really great customer support team that will be working with you to ensure that we're collecting the data that you're looking for. All the deployments will go well, and they'll be connecting with you pretty frequently after deployment starts occurring. So it's just a matter of really putting it all together into a nice dashboard in the way that you want it to look, and then getting that data to you. It could take maybe a couple weeks to at most up to a month, depending on if you're putting a robot in the line or whatnot.
Cool. And then this isn't a question from the group, but maybe if you could explain our deployment process for the vision and robotics, that's always interesting.
Yeah. So when it comes to the vision's a little more straightforward. Usually, you'll just need some internet or fiber runs up to it, a compute panel, and then on top of that, the power to those locations. The bigger difference would be that you would need air if you were to add a robot on the line in area as well, and it would require some extra panels around it. We really try to work with you guys though to be as plug and play as possible. So whatever your line is and your configurations are when we do those site surveys, we're getting those 3D scans, we're getting those measurements, and we're factoring all that into our models with our team in the solutions engineering side, as well as our deployment robotics, to really try to just integrate it into your environment with the least amount of changes as possible.
Yeah, and we always try to do it on weekends or downtime, things like that, so we don't interrupt your operations at all. And it's super quick and simple.
I've seen them do multiple robots over the course of a weekend. Our team's great.
Yes, perfect. Next question is, do you have customers that use only vision?
We do. It really just depends on what they're trying to get out of it, whether determining if adding any form of additional robotics in the line is there, if they're tracking equipment help upstream, or even if they're working on trying to mass balance around things for tuning their processes. Um, it we do though, and it's really interesting working with them and understanding their needs and use cases.
Perfect. Next question is, does your company sell the vision system separately from the robotics? And is your company collaborative on integrating with other systems, reporting modules, and interfacing?
So, great question. Yes, the visions can be sold separately from the robots, first and foremost. And then for integrating with other systems and reporting modules and interfacing, our team works with you guys on that. And we're working with like whether we can do the APIs for SCADA and other things. Happy to really connect with you on that, especially if you have a specific use case that you want to explore. My contact's right there. Feel free to reach out. We're always happy to schedule a call to really discuss your needs.
Awesome. That's all the questions we have right now, but I'll give it a minute or so to allow people to put any final questions in the chat. While we're waiting, I just want to say again that this webinar will be sent out sometime within this week, so you guys can refer back to it or send it to your colleagues. We also have a bunch of webinars that we've hosted over the past years on our YouTube and our website that you can check out. And we will continue to have these webinars running pretty much monthly through the end of the year. And later in the month, we're going to have like a pretty big announcement that will correlate with a webinar. So keep an eye out for that. I think, oh, we got another one. Is your company open to collaborating on solutions to assist your current customers in future ones? For example, reporting compliance solutions for EPR.
That's a great question. Um, I don't know if I'm the correct person to answer that for you. And again, I'm always happy to connect you with someone more in terms of how we can best assist you with what you're going for. But yeah, my boss
Yeah,
might be the best person to talk to on that.
yeah, feel free to reach out to Ted or myself. Both of our emails are on the screen, and we can discuss what you're thinking and connect you with the correct person um, to talk to about that. Let's see. All right, I think that's it. So, thank you everyone for joining us today. And as a third reminder, keep an eye out for an email from me with a link to the recording. If you have any questions or want to get in touch with us, again, our emails are on the screen. And please send us an email. We would love to discuss any thoughts, ideas you have, collaboration, anything like that. So thanks again for attending. Thanks, Ted, for the presentation. And we hope you have a great rest of your Tuesday and the rest of your week.